right, so let's go ahead and do area and perimeter number 2. It says the area of a circle is equal to 9 pi. Which of the following are true? So the area formula for a circle is pi r squared. So what I'm going to go ahead and do is replace a with 9 pi. And then I'm going to divide both sides by pi. So 9 equals r squared. So I'm going to square root. So my radius is 3. So radius being 3, that is a true statement. Well, if the radius is 3, the diameter is double, so 3 times 2 is 6. And then make sure you test all of your choices. So the circumference formula is pi times diameter. Well, I know my diameter is 6, so my circumference is 6 pi. So all 3 of those are true. Make sure that you check all your answer choices. Number 2, I think number 2 is the hardest problem on this worksheet. There's a lot of stuff in this problem that makes it challenging. It says that we have a circle inscribed in an equilateral triangle. That lets us know that all the sides of the triangle are the same. If the radius is 1, what is the perimeter of the triangle? So I'm going to go ahead and draw my radii in. And if the shape is inscribed, it means that all those sides are tangent. So I know that all of these angles where the radii meet the circle is 90, okay? So stick with me. This problem is going to be a little weird. Now, we broke the circle up into 3 angles. So 360 divided by 3 is 120. So all of these little angles are 120. Now, we have a quadrilateral. Quadrilaterals have to add up to 360. So to find the missing piece, I'm just going to take 360, subtract 90, 120, and 90 to get an answer of 60. So all of these angles are 60. We know that that's true. It's equilateral, so we can put 60s in all the corners. Now, for me to find perimeter, I have to find the measurement of this distance. I got to find the measure of that distance. Now, I don't have any special formulas for a kite like this, but I do have a triangle. So let me grab another color here. So if I take this shape and break up this little kite-looking figure, I end up with a right triangle. I'm going to draw it here. Again, my x corresponds to this. Half of 120 is 60, and half of 60 is 30. So what I end up getting right here is a special right triangle. Okay. Now it does tell us that the radius is 1, so the radius here is 1, which means that this measurement is 1. This is the short leg, and this is the long leg. So my long leg formula is the short leg times the square root of 3. So the short leg is 1. Well, we don't really write the 1, so it's just square root 3. So my long leg measurement is square root 3. So if I go back up to my picture, this distance is the square root of 3. However, I'm not going to pick f because the square root of 3 actually appears 1, 2, 3, 4, 5, 6 times. So our perimeter is 6 square root of 3. So this problem is very challenging to think about because you're actually breaking up your shape into special right triangles and then kind of working backwards. Number 3, in the figure below, we are trying to find the area of the shaded portion. It does tell you that the length of PQ is 2. So that means that the area of the square is length times width, so 2 times 2 is 4. So in our main problem, we will be doing 4 minus because we have our area of our large shape as 4. Now we have to do the area of a semicircle. So the radius in this measurement is half of 2, which is 1. So the area of a full circle is pi r squared. So pi times 1 squared is pi. However, I have a semicircle, which is half of a circle. So I have to make sure that I divide my area by 2. So my area of the circle that I'm removing is just half. 4 is the full measurement of the square, and then I'm subtracting pi over 2 because it's half of the area of the circle, which is option H. So be very careful when you're working with semicircles. Semicircles are half of a circle, so you actually do have to divide the area in half. Number 4, in the figure below, PQR is inscribed. What is the area of the circle? Well, if you notice here, we have 2 congruent measurements. That lets me know that this is actually a 45, 45, 90 triangle, and the hypotenuse measure actually is represented by the diameter. So the hypotenuse formula in a special right triangle is the leg times the square root of 2. Well, the leg measurement is the square root of 2, so the square root of 2 times the square root of 2 is just 2. So the full distance for the hypotenuse is 2, which means the hypotenuse is technically the diameter, so our radius is half of that. It's 1. So pi times 1 squared is just pi. Option C. So anytime you're dealing with circles, a lot of the times you're going to have special right triangles. So it's very important that you recognize special right triangles as well as their formulas. Saves you a lot of time and energy. Number 5, if the circle has a radius of 1, what is its area? So pi r squared. Pi times 1 squared is 1 pi, or pi. Option G. Just a basic formula question. 6, we're trying to find the area of the shaded region. So it says in the figure below, we have an inscribed circle. One side of the square is 8. So this is an 8 by 8 square. So the area for a square is length times width, so 8 times 8 is 64. So we will be having 64 as our first measurement, and we are subtracting, so clearly it is J, just based on the area formula for a square. However, let's continue. The radius measurement is 4. So the area formula for a circle, pi r squared. Pi times 4 squared is 16 pi. We are subtracting those areas, which is option J, 64 minus 16 pi. Remember, squares and circles, you can never combine them together. So chances are you're going to have pi in your answer as well as a whole number or a decimal. All right, in the figure below, the radius is 1. So here's the center. That means this and this are 1. What is the area of the shaded region? So the first thing I'm going to go ahead and do is find the area of my triangle. So to find the area of my triangle, I'm going to do 1/2 base times height. So 1/2 base times height. In the triangle, it's hard to tell because it's tilted, but if you turn your paper, this one is clearly the base and this one is the height, but it doesn't necessarily matter because they're both 1. So 1/2 times 1 times 1 is 1/2. So I will be removing the area of a triangle, which is 1/2. Now, to find the area of the shaded portion, we need to envision a sector. So we're actually going to do the area of a sector. So I'm going to put subsect. So area subsector. The area of a sector is pi r squared times the angle over 360. So pi times 1 squared times 90 over 360. 1 squared times 90 over 360 is 1/4 times pi. Now pi usually goes into the numerator, so this would just be pi over 4. So the area of the full sector is pi fourths because it's 1/4 of a circle, minus, I'm going to remove the area of this triangle. So to remove the area of the triangle, I would be subtracting 1/2. So it's option J. Number 8, 2 circles with radii r and r plus 3 have areas that differ by 15 pi. What is the radius of the small circle? So here is my large circle. The radius of my large circle is r plus 3. When I subtract the area of my small circle, which is r, their areas differ by 15 pi. Okay? So the area for the first one is pi. The radius is r plus 3 squared, minus pi r squared. When I subtract their areas, it must differ by 15 pi. We want to know the radius of the small circle, which is represented by r. This is mostly just guess and check. So the correct answer is J, and let's talk about why. Pi, 1 plus 3 is 4, minus pi times 1 squared has to equal 15 pi. Well, 4 squared is 16, so 16 pi minus 1 pi does in fact equal 15 pi. So the radius of my small circle is r, and the number that we used for r is 1. So there's really not really a nice way to kind of do this. It's just guess and check. You set up the equation, and then you subtract the areas to see which area difference gives you 15 pi. Number 9 mixes trig with excuse me, triangles. So in this problem, it says the sine of theta is 1 over 2. So that's O over H. Opposite is 1, hypotenuse is 2. Then we need to find the sine of phi. So the sine of phi would be the opposite side here over the hypotenuse. So our final answer is going to be over 2. So that kind of narrows down my answer choices. So over 3, over 3, over 3. So it's either H or K. So to find the measurement of the opposite side, I'm going to do Pythagorean theorem. 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4. When I subtract 1, I get 3. And when I square root, I get the square root of 3. So the opposite side measurement is the square root of 3 over 2, which is option H. So in this problem, you do have to use Pythagorean theorem. Remember, Pythagorean theorem exists. You can use it at any time when you have right triangles. And a lot of the times when you're doing trig and you're missing a side, Pythagorean theorem is the best option. All right, number 10. In the figure below, the area of the square is 2 inches. What is the area of the circle? Well, the area formula for a square is length times width. But we do know that squares have the same measurement. So I'm just going to put the length and the width as x. So area equals x times x. It does tell us that the area is 2, so I will replace a with 2. X times x is x squared. So I'm going to go ahead and square root. So the square root of 2 is equal to the radius. Well, I now need the area of a circle, which is pi r squared. So pi times the square root of 2 squared. Square root of 2 squared is just 2 pi. Option C. So to do this problem, you do have to know that the length and width of a square are equal. So we can use the same variable to represent that, and then it's squared. So when we find the length and width, we get the square root of 2. Be very careful. The radius here is not 1. 1 times 1 is not 2. 1 plus 1 is 2. So be careful. All right, next one. In the figure below, ABCD is a rectangle with sides AB, BC, and CD touching the circle. That just lets you know that it's touching at all parts of the circle and that these are tangents, so these are 90-degree angles. The radius is 2, so from here to here we have a radius that is equal to 2. What is the area of the shaded region? Well, if this length is 2, this distance is 2, creating this measurement of 4. Now, as we go around a circle, the radius doesn't change, so the radius is 2 here, making this measurement 2 as well. So now I have a circle with radius 2 and a rectangle that's 4 by 2. Length times width, 4 times 2 is 8. 2 squared times pi, we get 4 pi. However, in this problem, we are only working with this half circle. Like this portion up here just isn't there. Like if I cover it up, it's just a half circle. They're just trying to make the problem look harder by drawing the full circle, but you don't need the full circle. So what we have to do, remember, we only want half the circle, so we have to divide the area in half. 4 divided by 2 is 2 pi. So the area of the larger rectangle is 8 minus the half circle area of 2 pi, leaving me with an answer of C. Number 12, in the figure below, what degree is the smaller of the two angles formed by the hour and the minute hand? Well, in this problem, this is broken up into 12 equal pieces. So 360 divided by 12 is 30, which means that this portion, 30, 30, 30, and 30. 30 times 4 is 120, so this angle is 120. To find the remaining angle, I can do 360 minus 120 to get 240. So in this problem, this angle measurement is 120, and the other angle measurement over here, this large angle, is 240. We're looking for which angle is the smaller of the two. Well, the smaller one is obviously 120. Number 13 has been cut off by the copier, so here are our answer choices. 2 pi is F, 4 pi is G, 8 pi is H, 16 pi is J, and 32 pi is H. All right, so if the area of a square inscribed in a circle is 16 centimeters, what is the area of the circle? Okay, so to do this problem, you have to first find the value of the radius. So in here, I'm going to draw a circle. The square is inscribed in this circle, okay, which means that the corners of the square touch the circle evenly. And like, this is the worst drawing ever. I should have traced something to draw this circle. It tells you that the area of the square is 16. So the area of the square is 16. Remember, length times width, these are equal. So if I divide 16 by 2, or excuse me, not by 2, if I square rooted that, I would get 4, because 4 times 4 is 16. So the length and width are 4. Now, I need to find the area of the circle, which means I need a radius. I need to know what that is. That's my radius. However, I can actually turn this into a right triangle, because if I were to continue to draw this, the diagonals of a square are always perpendicular. So what I actually have is a 45, 45, 90 triangle. So I'm going to redraw that triangle out here in the open. This is x, and this is 4. So this is the hypotenuse. The hypotenuse equals the leg times the square root of 2. So 4 times the leg square root of 2 divided by the square root of 2. I get 4 over square root of 2, which is not correct. So I need to make sure that I rationalize this. Multiply the top and bottom by square root 2. I get 4 square root 2 over 2, which reduces to 2 square root of 2. That measurement is now my radius of the circle, because if I go back to my main picture, we had our right triangle. We were trying to find the radius. When I drew my triangle off the picture, we found the radius to be 2 square root of 2. So the area formula is pi r, which is 2 square root of 2 squared. I must distribute the squared. So 2 goes to 2, which is 4. Square root of 2 times 2 is 2. 4 times 2 is 8 pi. So my area, correct answer is H. That problem is very challenging. There's a lot going into it. It's hard because you have to draw the picture and then you have to recognize that it's a 45, 45, 90 triangle. So number 13 is a very tricky problem, but it's a lot of just the repetition of special right triangles. All right, let's get out of area and move on to number 14. I lied. This one involves area too. So we'll finish up with area using tangents and angles. So it says, in the figure below, 2 circles have a diameter of 2. So from here to here, this is 2. From here to here, this is 2. Making this measurement 4. Okay. We want to know the area of the shaded region. Well, if this is 4, then this is also a diameter, so it's 2. So the area of the large rectangle is 4 times 2, which is 8. So it's going to be 8 minus something. So we know all these are out because 4 times 2 is 8. So if the diameter is 2, that means the radius is 1. So pi times 1 squared is just pi. So I'm going to subtract the area of the first circle. And these are both the same. So I'm actually subtracting the same area twice. So pi minus pi, we get 2 pi for option A. If you choose option B, you're only subtracting 1 circle area, and we need to make sure we're subtracting 2. Number 45, what is the measure of ABC? So here is the angle. In this problem, it gives you that the central angle is 70, which means this arc that it crosses is also 70. Central angles and the arc that they cross are equal. Now what we have, if I were to remove the central angle, I'd have my x value here, and I have this arc as 70. Well, I know when I go into an inscribed angle, I must divide by 2, so half of 70 is 35, option J. So this problem uses central and inscribed angles to kind of help you. Next, number 16. QP is tangent to the circle at P and QR is tangent at O. That lets me know that these are both 90 degrees. What is the measure of the minor arc, PSR? So we're trying to find this arc measure, but remember, this angle is actually the same because they're central. So what we actually end up having here is a quadrilateral. We know that quadrilaterals always add up to 360 degrees. So 360 minus 90 minus 90 minus 60 is 120. So that means that x is 120. Then so is our arc because it's central. So the correct answer is J. That one involves central angles as well as knowing that quadrilaterals add to equal 360. Number 17. We're trying to find the area of the shaded region. So it does tell you that the radius is 2. We've got tangent lines, so we know these are 90. We just did a problem like that, but again, you would add it to equal 360, so our arc is 120, so our angle is 120. Again, that's just like number 16. So we're trying to find the area of this sector, so pi r squared times angle over 360. The radius is 2. The angle is 120. So 2 squared times 120 over 360 is 4/3 pi. Pi always goes in the numerator whenever you're multiplying like this, so it's 4 pi thirds, which is option J. Number 18, in the figure below, the diameter is perpendicular. It tells you that chord CD is 8, so we know that this whole distance here is 8. But we do know that these are broken up into 4 and 4. It bisects. We know that O to E is 3, and we want to know the length of the radius, so I'm going to draw in the radius. Hopefully, right off bat, we see a right triangle, and I have lengths 3, 4. By default, this one's 5. That's a 3, 4, 5 triangle. So just recognizing 3, 4, 5 triangles makes this problem a lot easier. All right, last page involves area equations of circles. So to start, here's number 19. Okay. We want to know what coordinate would be represented by x, y. The best thing I have for you is just to graph it. So let's graph -4, -4. So if I graph -4, I go negative in the x, negative in the y. It would be somewhere down here. That does not overlap here. This is what we're trying to overlap. So A is out. B, -3, -3, again, down below. C, -2, -3 would be somewhere down here. Option D, -3, but a +2, that would overlap here. And to test option E, +3, +2 would be somewhere over here. So E is out. So for here, all I would do, instead of trying to stress out and find that equation, I would just graph your answer choices, and that's going to make it a lot easier. All right, number 20, which equation of the line is represented? So remember, the center point is always opposite of what it looks. So this looks negative, which means it's really positive. If I have nothing here, the number that's represented by nothing is 0. So 1, 0 is my center. 1, 0 is here, that's not the center. 1, 0 is here, not the center. 1, 0, not the center. 1, 0, not the center. 1, 0 is the center. It's option D. So just plot the center point and go from there. Number 21, we want to know what the circumference of the circle is. So the circumference formula is 2 pi r. In the equation of a circle, we have the 16. Remember, the 16 is represented by r squared. So the square root of 16 is 4. So I'm going to go in here. 2 pi times 4. 2 times 4 is 8 pi. The correct answer is D. So you're just kind of using the formula to help you get circumference. Okay, last problem. Circle with center 4, -5 is tangent to the y-axis. What is the radius of the circle? So I'm going to go ahead and draw the circle first. And we know that it's tangent to the y-axis. Okay. So 4, 1, 2, 3, 4. down 5, 1, 2, 3, 4, 5. Sorry, it's like a poor drawing. So 4, -5 is located here. If we want to know the measure of the radius is located from the center to the point on the circle. Well, that distance, if I kind of follow up here, that distance is 4. So the radius of the circle is 4. Plotting a little picture will definitely help make these problems easier.